Hello, my name is Axel Ahrens. I'm a postdoc at the Technical University of Denmark in the Department for Health Technology in the group of hearing systems. Today, I'm presenting to you a short workshop on an introduction to R for psychoacoustics, or my procedure to analyze perceptual data. The reason why I'm doing this, commonly in psychoacoustics, we are collecting data using MATLAB. And MATLAB has been great in the last couple of years to improve their way on how audio can be played back, on how experiments can be programmed. They are very nice interfaces to code user interfaces. So MATLAB makes it very easy to play back audio, to process audio, and to collect data from listeners. However, MATLAB is not as great for data visualization, so making plots that are very nice for publications or presentations, and it's not perfect for statistical analysis. This is a disclaimer, this is my opinions. I think also for statistics and for data visualizations, MATLAB has improved a lot over the last couple of years. But I think there are better ways on how you can visualize data and how you can analyze your data. And I believe this is best done in R. So what I present to you today is how you can take your data from MATLAB, export it into or import it into R, and then visualize and analyze your data in R. So what we'll talk about, first of all, I show you my way on how to prepare data in MATLAB. Then how I export it. Then we move into R, and I show you how I import data using the Tidyverse and how I visualize data using the Tidyverse or ggplot2. And in the very end, I will talk a little bit about statistical analysis with mixed linear models using LMER test. And as a disclaimer, this is only my workflow. There are probably more efficient ways. So if you have any comments, if you have any improvements, I'm very happy if you let me know. So let's talk a little bit about data. In MATLAB, as MATLAB very much likes to work with matrices, my data generally looks like this. So I have often a data which is like possibly 4-dimensional, depends on my experiment. So the data is like a 10 times 3 times 2 times 3 matrix, where the first dimension, for example, are the 10 different subjects of whom I collect data from. Then the first factor with 3 different levels, the second factor with 2 different levels, and the third factor with 3 different levels. So each dimension is a factor. And that's nice in MATLAB because you can very quickly access these dimensions and plot them or plot them all over on top of each other or whatever you like. You can calculate means. So that works very well. However, for R, there is a better way. And this is called to have tidy data. And there's a package or a group of packages called the Tidyverse. You can go on tidyverse.org to see more information about this. And I will talk a little bit more about what this Tidyverse is later on. Tidy data with a package called tidyr is set up in a way, is set up like this. So it's set up in tabular form. So you have different columns, and each column is one variable or one factor. And then you have rows, and in each row is one observation. So for example, you might have, as I talked before, the subjects in the first column, the factor 1 in the second, the factor 2 in the third, and the factor 3 in the fourth. And each data point is then in one of these rows. So for example, if you measure speech intelligibility, the first point is then in E here, so the 5th row is the speech intelligibility data of the first subject for the first level of the first vector, and so on and so on. So that's the nice way on how you can structure your data, but we need to move somehow from this MATLAB matrix style to a tabular style as we need this for R. And before we go into the code, I uploaded all the data onto GitHub, so you can find all the code here. So you can either download it or try to code along with me. The MATLAB code I will not code live, but I will try to do this with the R code so that you have the chance to just code along, because I think that's the best way how you can learn to code yourself. Let's start with MATLAB. So we have to prepare the data in MATLAB. Here's my MATLAB code for this, and I will go through this step by step. Let me start with making the font size a little bit bigger. Here we go. So we have a data set here that has been collected by one of my students and a little bit adjusted by me. And this data set is the speech intelligibility data set. It was collected for 7 different subjects in 4 different processing conditions. So factor 1 is the processing, and for normal hearing and hearing impaired listeners. So let's have a look at this data. So we have the SRT here. So we have a matrix that is a 7 times 4 times 2 matrix, as I talked about before. The 7 is the 7 subjects. The 4 are 4 different processing strategies, how the signals were processed before played to the subjects. And the last dimension, the 2, is the normal hearing and the hearing impaired, the number 2. So this is this matrix style. So now we need to create a tabular form out of this data. And there are probably better ways or nicer ways on how to do this. The way I do this is I reshape each of the variables. So I reshape the SRT to be a 1-dimensional vector. And then I make it in a tabular form that I have the subject names and the condition names and the normal hearing or the listener type, so normal hearing or hearing impaired in the last dimension, or in the as a vector. So this can, for example, look like this. So this is now called here SRT matrix. So the SRT matrix now is like one long vector. Instead of having it 3-dimensional, it has only 1 dimension. I have to create this to a cell because that makes it a little easier later to export it. Then I do the same, or I create a subject name array. So for each of these rows, I create from which subject this data was taken. So the subject data array then looks like this. So listener 1, listener 2, listener 3, and so on. And then it starts again with listener 1 and so on, and goes all the way down. Then we go here to the condition name array, which contains the conditions, the same as before with the listeners, but now with the conditions, with the processing strategies. There are 4 different processing: a reference, processing 1, processing 2, and processing 3. And the same with the listener type. Here we go, which is hearing impaired, HI or NH normal hearing. So this data we can now merge and write as a CSV file. First, we create a header of this table where we have subject, condition, listener type, and SRT. Then we create a big array of data, or a table basically. And then we actually create a table from MATLAB. So MATLAB has a data format that is called table. Create this here, and we can have a look how this looks now. So we have this table here with subject number 1, subject 2, subject 3, and so on. And then we have reference, processing 1, and so on, and all the SRT values for each of these observations. Then we write this as a CSV file. We do this here. And as we can see, we have created the data for r.csv. And this we can now analyze in R. So let's go back to our presentation. We now exported the data from MATLAB. And now we want to move it into R. And before we go into this, I will talk a little bit about this Tidyverse that I talked about earlier. The Tidyverse introduces a couple of packages, and these packages introduce some data handling and some coding that is slightly different from the base R. And there's a great book that's called R for Data Science that you can find from this link, or also when you go to the webpage of Tidyverse. It gives a super nice overview on how you can use all these functions, and generally gives a nice introduction on how to use R in a slightly, let's say, non-traditional way. Generally, there's a big discussion, let's say, what is better, if people should use base R, so the normal R, or if people use the Tidyverse. And I think many people use mixtures. Under this link on varianceexplained.org, you can find an opinion piece that is, I think, quite nice, that discusses a little bit what is better for beginners, if they should use base R or the Tidyverse. For this example now, I mainly use packages from the Tidyverse, which I find are very well working with my workflow. A little bit more on R and the Tidyverse. What we will use today is a package called readr, which is part of the Tidyverse that we can use to actually read the data from a CSV file. But there are other ways to import the data. You can do it also manually in R by clicking on in RStudio by clicking a couple of buttons. Or if you have an Excel S or Excel SX file, you can read it with this function. And they're very nice help functions or help texts on these links. To manipulate the data, so to either reorganize it or to change some information, you can use tidyr or deployer or data table. These are all nice functions. Data table is a base R function, while the other two are from the Tidyverse. Then for data visualization, I will show you ggplot2. Be aware, I will not give you a very detailed introduction on ggplot2. There are very nice resources online where people explain ggplot2 very nicely. And I will also get back to this very briefly. And then in the end, I will talk a little bit about data analysis, and you can see some vignettes. Vignettes are like more or less short information pieces or examples on how packages can be used. And the two packages that I will use today is LMER test and EM means, but I will also get back to these two a little bit more into detail. Okay, good. Let's get started with R. Let's open R. I have a fresh start of R here. And the first thing that we need to do is to install our packages or package groups that we need in R. And you can do this by typing install.packages, and then in quotations you can write the package name Tidyverse, for example, and then it takes a little time. And if you have I have already installed, but if you don't, then this takes quite a while because it installs quite a bunch of packages. You have to repeat this with two other packages. So let's start here with packages. The first that we already installed is the Tidyverse. The second package that we need is LMER test, as I said before. Remember that you have to install it in the same way with install.packages before you can load this. And the third package that we need is EM means. The EM means is for post hoc analysis. This function is for linear mixed models. And we talked a lot about the Tidyverse. The Tidyverse has many different packages. The next thing that we would like to do is to load the data. So let's first, with Control and Enter, you can run a single line. So we have to do this for all these lines. So then let's start with loading our data. The first thing that we would like to do is to set the working directory. And I will set my working directory here. And you can press Tab to get to a certain folder. I have mine in Users, Documents, Tab, in my repositories, and then it's in Intro Psychoacoustics. So we run this line to set the right working directory. And then we want to create our data frame. Here, you can use this assignment operator, but in most cases also the equal sign works equally well. Again, that's a specialty in R, that this assignment operator is used generally instead of an equal sign. But for most things that we do here, or I think for all things that we use here, you can equally use an equal sign. And I might switch a bit back and forth between both of them. Again, you can find a lot of resources online where you find more details on the reasons why to use the assignment operator or the equal sign. We want to read our CSV file, so we use the function read CSV, and the function is called data for r.csv. So this we can load now. And now we can see here on the bottom again, let me try to make this a little bit bigger again. Tools. Let me see if I can. Let's go into Zoom. Okay. Okay, so that should be a bit easier to read now for you. So here we have now we read the CSV file, and it was passed now. We can also have a look at this. So if we press Control Enter while we have marked a variable, we can have a look at this. And what we have now loaded is a file, or it's a data format that's called a tibble, which is like a table in R, specifically for the Tidyverse. Again, you can find more details on why is this a tibble and what's the difference to a common data frame online. And this tibble is a 56 × 4 array where we have 56 rows with all our information, as I showed you before, and then the conditions, the listener type, and the SRT. Right now, the subject has the data format as a character, as well as a condition, the listener type, while the SRT is a double. And the double, that makes sense for the SRT, but here we don't want to have a character for the condition or the subject or the listener type, but instead we would like to have a factor. And we can do this, and I will just copy and paste this now to make this a bit quicker. We can also load the data frame and say which types the columns should be. So subject, for example, should be a factor, condition should be a factor, the listener type should be a factor, while the SRT should be a double. We don't need to define this double here again, because it was already automatically detected. But to be on the safe side, I always prefer to define each column again manually. Also, what you can do here, you can define an order of the levels within the factor. So for example, for me, I would like to have the reference as the first, then the processing 1, processing 2, and processing 3. As a standard, this is sorted alphabetically, but I prefer to have it like this. So let's load this data frame like this and have again a look how the data frame looks. And now you can see that we have a factor, a factor, a factor, and again a double. So now we have read in our data. The next thing is we would like to make a plot. So we imported the data now, and now we want to visualize this data. To visualize the data, we use the package ggplot2, which is part of the Tidyverse. And if you would like to have an in-depth overview or an in-depth discussion on what ggplot2 is and what it can do, you can follow this YouTube link. Thomas Pedersen did a very nice workshop where he explained all the details of ggplot2. I think it's a 2 × 2 hour workshop. So it takes quite some time, but it's really worth it to follow. If you want to know, have more information a little bit more quick, you can follow, you can check these cheat sheets. These cheat sheets are available for many of the Tidyverse packages and functions. Let me see if I can quickly go onto that page. So here we have a ggplot2 overview. And to get started, let's have a look into this part here with where we have a discrete x and a continuous y. So what we would like to plot is the continuous y, which is the speech intelligibility or the SRT, and the discrete x is the hearing impairment and the 4 conditions. And the first thing that is recommended to us here is to use the geom bar. So let's have a look at this first. Here. So let's make a plot. So we define a variable called f, which is holding the information from our plot, and we use a function called ggplot2, and we need to tell it which data we would like to use, and the data is called data frame. And then we can add the aesthetics. The aesthetics contain what we would like to have as an x, and we would like to have the x as a condition. So here's a condition, so the reference, processing 1, and so on. Our fill should be the listener type, and the y value should be the SRT. So now we created this f, and when we run this, let's move this up again, we see that we are getting an empty plot. ggplot2 is built in a way that the way of plotting is independent from the data. So you define data, and then you can plot multiple things on top of each other. So it's not that you call one function to be a box plot, one to be a pie chart, one to be a bar plot, but you always create an ggplot object, and then you can add things on top. So you have, for example, your data that we just added. We had a mapping, what x, y, and the fill should be, and now we can add what the how the plot should actually look like. So as the cheat sheet recommended, that when we have a continuous y and a non-continuous x value, that we can make a bar plot. So let's do that. So this bar plot or a column plot, geom is called geom col. You can see a lot of others here. So if you type geom underscore, you can find a lot of different ways on how we can plot things. We do this column plot, do this, and what we're getting now is a weirdly stacked bar plot. Now, if we would like to use, instead of having this normal hearing and hearing impaired stacked on top of each other, we can use position equal position dot And this now calculates automatically the mean over the subjects, and then plots the normal hearing and the hearing impaired data. So it gives us automatically a legend and gives us the first information on what we're interested in. However, using this column or bar plot is not such a good idea. I mean, it always looks like we are comparing something to 0, or there's an amount relative to 0. This doesn't really make sense for speech intelligibility data. So instead, what makes more sense if we use a box plot. For this, instead of saying f, so the f that we created here, plus col, we use f plus the geom box plot. So let's run this and see what we're getting. And now we're getting a box plot with the data, which in my opinion looks already much better. This makes much more sense to analyze. Let's pull this a little bit bigger so that we can have a brief look at the data. So on the x-axis here, we have the reference, the processing 1, processing 2, and processing 3. So these 4 conditions that were measured, and the 2 different colors. So the fill is the normal hearing and the hearing impaired data. And on the y-axis is the speech reception threshold, or the SRT, or the speech intelligibility. For SRT, the more negative means better speech intelligibility. And what we can see, the normal hearing listeners here are better generally than their hearing impaired counterparts. So this is a really good start. But we can do a bit better. We can tweak this a little bit. ggplot2 has this gray background. Some might not like it. Some might like it very much. So there are some default parameters. So theoretically, you could use this figure now and already show this. But we would like to tweak it a little bit and make it a little bit more beautiful. And one thing that we can do to do this is to actually add the actual data points. So now we have the box plots, but we would like to know how does the data behind this actually look. And for this, we can, for example, use this function called geom jitter. And for this, we would like to add a little bit of an aesthetic, because we would like to add a color here, which should be the listener. Let's have a look how this turns out. There's a function typo, obviously. So now we have in red and in green the data points from the normal hearing and the hearing impaired plotted. However, they seem to be a bit all over the place. So what we can do to fix this, in this geom jitter, we can give it an option called width that we can set to 0.1. And we can also say, okay, we don't like these dots. They look too similar to the outlier data. So let's have a shape that is different. Let's use this shape 4, which are crosses. So now we have the jitter is not as big, so it stays here more in the middle. And we have the red crosses and the green crosses for normal hearing and hearing impaired data. So now we also have the individual data of each of the listeners. Okay, so now we have our data presented. Now let's get rid of this gray background. So what we can do, we can just copy this. Let's make a bit of space here that it gets a bit more separate. And we can actually go into multiple lines. That makes it a bit more easy to read. And we are adding things step by step. So what we now want to add is that the scene is getting black and white instead of having this gray background. So now we have a white background, but there are multiple ways in what you can do. We can use classic, for example, that removes the box out here, or whatever we like. You can find a lot of information online to make this even nicer. The next thing, the labels are not very nice, so let's change a bit the labels. For example, we would like to have the Y to be called SRT in dB. And we want to have the X without anything, because this is already self-explanatory, so we don't need to define any conditions here. Then let's have a look at this. Yes, that looks already nicer. So now we have nice labels everywhere. One thing that we can add now is we can increase the font size a little bit. We can do this in this theme. Let's go again to the next line. And we define the text as element text to be the size equal 60. And now our font size here everywhere increased. So now we have a nice figure that we can put into our paper or into our presentation. And we can save this, for example, as a PNG called plot.png. You can have multiple information or multiple variables here to change the size. So we now have the standard size seems to be this. So that's what it's saved on. So now we have a nice data set that we have plotted. We have a fairly beautiful figure. So now we can look at this figure and say, yeah, but is there actually a difference between these 4 different processing strategies? And for this, we can use a statistical analysis. For most data, I'm using mixed linear models. So we fit a linear mixed model to the data, and then we can remove factors or interactions from the model if they turn out to be not significant. And last but not least, we can use a post hoc analysis to see if there are any differences within factors. To do this, I like to use a package that's called LMER test. This LMER test was developed at DTU Compute. So we have the experts on this package just next door. And for the post hoc analysis, I'm using a package called EM-means, but I talk a little bit about this when I'm getting there. So let's go back to R and do some. The first thing that we would like to do is we would like to fit a model. It is important, this LMER function exists in multiple packages. So there's, for example, a package called LME4, where you have this kind of function. So be aware that if you want to use a specific function, that you need to load the library LMER test. That is very important. So the input variables of this function is basically our model. So what we would like to fit is the SRT. And we have multiple factors that we would like to fit to. One of them is called condition. And we would like to have all interactions with the listener type. And additionally, we have one random factor, which are our subjects. So far, the model or the function doesn't know what data we are using, so we can say data equal data frame. To make this a little bit bigger again. Here we go. So now we can fit our model. Let's run this. And I had a typo probably. Let's go back to data frame. Subjects are actually called subjects, but subject. But condition and listener type seem right. Yes. So now we fitted our model. We can also have a look at the model. But what's more interesting, now let's give it a bit more space here. But what we need to do now as the first step is to see if there are any factors that actually are not significant that we can remove from the model, that we can simplify the model. And the great thing of this LMER test is it has a step function. The step function is removing factors in the correct order. So you don't need to be careful in removing the right interactions first. This function is doing this automatically for you. So we can run this, and we can also have a look what we got here, and we already get an ANOVA table here. We get information first on the random effect, and then on the fixed effects. And as we can see, it says here eliminated the interaction between condition and listener type. This is not significant, so the function knows, okay, this can be eliminated. So what we can do now, okay, we eliminated something, so let's fit our simplified model. And the simplified model consists, we can get this by typing get model of step results. Alternatively, we could just say, okay, there's no interaction between these two, so we can just remove the multiplication here. So you could just say plus instead. But when you have a lot of factors and a lot of interactions, using the step function makes the life much, much easier, and you can iterate much more quickly. So now we have our second model, and we can do an ANOVA of this model 2, and we can do a RANOVA of that model 2 as well, which gives in the end the same results here for the RANOVA, significant, and they give very similar or even the same results than we saw before from the step function. So what does this mean? So now we see that the condition and the listener type are both highly significant. So let's do a comparison. Let's have a look at this plot. So first of all, we see that the listener type, so normal hearing or hearing impaired, there's a fairly clear difference. And this difference is something like, I don't know, about 3 dB. So it's not surprising that this turns out significant. On the other hand, the 4 different processing strategies also seem to be different, even though they're much more similar to each other. But since we have 4 different processing strategies, we now would like to know which of these are actually different from each other. The reference and processing 1 don't really seem to be very different, while maybe with the reference and processing 2 and the reference and processing 3, they might be different. And for this, we do a post-hoc analysis, and we use the package called EM_means. And let's write this to a variable. And in this EM_means, we load our model 2. And what we're interested in is not the listener type, but instead the condition. So we can just run this on the condition here. Now it complains that I miss a package, but it still created this EM_means. And then we can run a test on this. And this test is checking if any of the different conditions is significantly different from 0. Be aware here that we are ignoring an effect of listener type. As since we didn't find an interaction between condition and listener type, we can just look either at the condition or the listener type. Since the listener type has only 2 levels in the factor, it's not very interesting to look at this per se, at least when we would like to know a bit more about if there are any more differences. So let's have a look only at these 4 conditions. So let's run this test, and what we see, not surprisingly, all 4 conditions are significantly different from 0, which we could have guessed before. So what is more interesting to look into is to do the pairs EM. So this does an actual paired comparison across all these conditions. So when we do this, we get a contrast between the reference and the processing 1, reference and processing 2, and so on, up to processing 2 versus processing 3. So now we can have a look what turns out significant here. Before we do this, we can see what's significant here. For example, we see that the reference versus processing 3 is highly significant. So the reference and processing 3 seem to be quite different. Similarly, processing 2 and processing 3 seem to be different as well. So if we would have more information now about these processing strategies and what the reference actually means, we could do a more detailed analysis and figure out how good or bad these processing strategies are working. As a standard, EM_means chooses a p-value adjustment that fits to the data, but in some cases you would like to change this. So what you can do is you can add an input variable and say that you would like to do this adjustment based on, for example, Bonferroni. And then you can run this again. And now you see that the p-value adjustment is using Bonferroni for 6 tests, and that the p-values have slightly changed. Okay, so this is a method on how I am analyzing perceptual data that has been collected in MATLAB that I then export and import into R. And then I'm using the Tidyverse LMER test and EM_means to further analyze my data. If you have any questions about this, I'm very happy when you get in touch with me. You can find all the code on GitHub. I can put up the link again. So you can find all the information here. You can also find my email and all my contact information there. So if you have any questions, feel free to get in touch. Thank you for listening to my workshop.